Hi everybody, welcome to section 9.1b. Let's get some graphing done. So we have analyzed, picked out all the things, found the axis of symmetry, found the vertex, found the y-intercept, found solutions if it's possible. Now we're going to get all these guys on a graph. So how do you graph a quadratic equation? This is going to look really familiar from 9.1a. First thing you want to do is put your axis of symmetry on the graph. I'm going to draw that in as a dotted vertical line. Everybody knows which way vertical is, right? I'm going to put that in as a dotted vertical line. We mentioned in 9.1a that axis of symmetry is a mirror image. So you can use that dotted line to help you graph and to make sure everything is symmetrical and it all lines up nice and neat like a mirror image. After you do that, plot the vertex. Remember, the vertex is an ordered pair xy, and it lies on the axis of symmetry because the first half of the vertex is the same value as your axis of symmetry. Everybody remembers what that axis of symmetry equation is, right? X equals. So we're going to use that answer from negative b over 2a, put that into the equation to find the rest of the vertex. Once you put that dotted line and your vertex point on the graph, put the y-intercept on the graph. Y-intercept's on the y-axis. Typically, that'll give you another point. And I'm going to make a little note here. Use the axis of symmetry for a mirror image point. So really, as long as your vertex and your y-intercept are not the same, the y-intercept gets you 2 more points because we're going to have a mirror image point from our dotted axis of symmetry. Once you've done that, put your solutions on the x-axis. If you could factor that and you found solutions, those are x-intercepts. They're usually 2 separate points on the x-axis, and they should be equidistant away from your dotted axis of symmetry. So you know if you did that part right because they'll line up nice and neat for a mirror image. And last but not least, if you do not have at least 3 points at this point, make an XY values table so that you can get more points. That's an if. So if you don't have at least 3 points, make an XY table. We're going to do that for our third example. We'll do 2 examples. We've actually, if you look at these practice problems, these are problems that we already found the information in 9.1a. So I figured let's make this easy on ourselves and let's reuse our stuff because we already did all this. So why would we do it again, right? So take out 9.1a, look at this, let's fill in the blanks. Our first equation is x squared minus 2x minus 3. If I recall correctly, when we did this problem, we found axis of symmetry. We did negative b over 2a. We did the math, so we did a positive 2 over 2 times, that's a positive, over 2 times 1. So we found that x equals 1. So I'm going to go over to my graph. I'm going to find 1 on the x-axis, and I'm going to put a dotted vertical line. So that's plotting the axis of symmetry. Then when we plugged in the math, this looks exactly identical, by the way, I think, to what we did in section 9.1a. When we did the vertex, we knew it was going to be 1 something because we reused that axis of symmetry value. When we plugged in a 1 to this original equation, we got 1 squared minus 2 times 1 minus 3. We ended up with a 1 negative 4 for our vertex. So I'm going to go over to my graph. I'm going to go over 1 down 1, 2, 3, 4. And I'm going to put that point right there. Vertex. We said that this was going to be a minimum because our parabola is going to open up because our a value is positive. So we should, when we graph this, we should be like, oh yeah, this is definitely opening up. This is definitely a minimum point. The y-intercept is always our c value. Our c value in this case is negative 3. So I'm going to go on my y-axis at negative 1, 2, 3, put a point there. Now this is where I'm going to use that matching mirror image. See how I've got that dotted line? Well, if my purple point is 1 unit away from that dotted line, that means that the matching point has to be 1 unit away from that axis of symmetry. And last but not least, I believe we found the solutions. To me, that's not enough information to draw my parabola. I don't like it. It's too squinched together, so I'm not exactly sure what it's going to look like. But we found the solutions 3, -1 when we factored that guy. Factoring won't always work, but it did in this case, so I'm going to put those on the x-axis. Remember, these are our x-intercepts. So I'm going to go over to 1, 2, 3, put a point. I'm going to go over to -1 and put a point. Notice those are the same distance away from my red axis of symmetry. Now I've got enough information, enough points on my graph to draw a parabola, make it curved. It's not a V. Make it curved, put arrows on the end. And we graphed it. So once you find all that information, it's really easy to get that stuff on the graph. So let's quickly, I'm not even going to go through the math part, but let's go to this second graph. Negative at 2x squared plus 2x plus 4. Hopefully you did that math in section 9.1a. So I found the axis of symmetry was 1/2. The vertex from that section was at 1/2 something. I plugged that in and I got, wasn't it 4.5? We decided that was going to be a maximum value because my a value is -2. That graph opens down. The y-intercept we had at 4. And when we factored, we did have 2 solutions, 2 and -1, right? I'm trying to remember and think back and look. So let's put all this stuff. 1/2 is not an easy axis of symmetry, but we can figure this out. So I'm going to go to 1/2 on the x, and then I'm going to put a dotted line right down 1/2. Not great, but it'll work. My vertex falls on that axis of symmetry. So 1/2 over 1/2 up 4.5. 1, 2, 3, 4, and a little bit more. So there's my vertex, and we said that was a max. Y-intercept is at 4. Again, these guys are really squinched close together. 1, 2, 3, 4. There's my y-intercept. I didn't label that on my other. And do you see where I should have a mirror image point right on the other side of that dotted blue line? Is my mirror image point. And then my solutions, remember these are x-intercepts. So I'm going to go over to 1, 2 on the x-axis, and I'm going to go to -1 on the x-axis. Those look pretty much the same distance away from my blue dotted axis of symmetry. I've got 5 points on my graph now, so I'm going to go ahead and draw my parabola, opening down. Try to hit your points. It looks like I kind of missed. Remember to please put the curved lines, not a V, put the arrows going down this time since the parabola is opening down. All right. Last but not least, y equals x squared. Y equals x squared, this is the one that I asked you to finish, and this one is the one I want to make sure we talked about. So when we did -b over 2a, we got x equals 0. When we put 0 in for the vertex, we get 0, 0. We know that that's going to be a minimum point because our graph opens up. And our y-intercept is equal to 0. When we factor, we get 0. So if I set x squared equal to 0, I square root both sides. I guess it's the only thing I can do. And I end up with 0. There is not a whole lot of information on this graph. Zeros everywhere, right? My axis of symmetry, I go to 0 on the x-axis. There's my axis of symmetry. My vertex is at 0, 0. My y-intercept is at 0, 0. My solutions are at 0, 0. There's not enough information here to draw a parabola. So this is where I've got to make myself an XY table. and I've got to put some points in there. I'm going to use symmetry to my advantage. So right in the middle of this graph, I'm going to put my vertex. 0, 0. 0 for x and 0 for y. Now I'm going to count up to and down to. So I could do -1 and -2, +1 and +2. I'm going to put those into my equation, y equals x squared. So when I put a -2 in for that, please think carefully. What is -2 to the second power? Anytime you square a negative, what's the sign? +4, right? Same with -1. When I put a -1 into my equation and square it, -1 times -1 is +1. When I put a +1 into my equation, 1 to the second power, that's just 1. And when I put a 2 into my equation, 2 squared is 4. Even in our xy table, do you see the symmetry that goes around the vertex? I've got those matching points if I count equal on each side. So let's get these extra points on here. Let's finish up this parabola. So -2, +4 is my first point. -1, 1, +1, 1, +2, 4. I now have enough information to sketch my parabola. Please make a note, this is also our parent graph. We're going to talk about that in the next couple of sections and how does changing different things change our parent graph. Parent graph is our most basic function. So the origin's at 0, 0, opening up in our xy table. All right, so I left a couple blanks here because I'm going to ask you to use number 5 for the lesson summary. So first of all, in this box, please write down what you think is the trickiest part of graphing quadratics and what's the easiest part. So that could be all the way from figuring out what the values are, using -b/2a, putting stuff on the graph, making an xy table. There's so many things involved. So what do you think is the trickiest and the easiest parts of graphing these quadratics? And for your practice problem, using graph number 5, do this equation, y equals x squared plus 4x plus 3. I've got it all laid out for you in problem number 5. I want you to actually find all those things. What is the axis of symmetry? So start with -b/2a. What's the vertex? Is it a max or a min? What's the y-intercept? That will factor so you can find solutions for that graph. So go ahead and do that for your practice problem. I'll be looking for that in class, and have a great day.